knows a huge amount about sustainable design. As a systems engineer and educator, he's been practicing designer with 30 years of experience. And as I mentioned, he's a scholar of Buckminster Fuller, as well as authored a lot of works on him, one of which was in the UNESCO Encyclopedia of Life Support Systems. He's received a bunch of different medals, honors and awards for his ongoing work in education. And he's studied biomimicry and in fact is a biomimicry education fellow. Curt, I hope I haven't done too much violence to your reputation or embarrassed you, but you're on, and I look forward to your talk.
All right, thanks very much. Well, you're way too kind, Bedard, but appreciated. So I'm gonna see if I put this in full screen mode.
You also have something in, there you go. Okay.
Does that look right?
Yeah. If you wanted just one slide at a time, you can go, if this is a PowerPoint, you can click on Command 5, and that is the show version of the PowerPoint. But if you want to use it this way to see what's coming up, that's fine. Whatever works for you.
Okay, so what I understand is it's not showing. So let me move this back, and then we'll get it. Oops. Oh golly. Sometimes Zoom and I aren't. Okay, maybe we're okay as long as I didn't lose the meeting. Okay, I'm still there. Excellent. So we're going to try this one this time, and then try this. How's that?
That's fine. I mean, what?
So you still are seeing the slide sorter on the left?
Yes, we are still seeing the thing on the column on the left, but that's okay.
I kind of hate to have that happen, but that I had it. Come on. One more time and then I'll give up. Thanks guys for your patience with me. And thanks to all of you for participating in the Design Science Lab, the Global Solutions Lab, I should say. It's something that I often talk to people about as a great example of design science in action. Did I get it finally or no?
Yeah, that's the full screen. We're not seeing the upcoming slides on the left.
All right, thank you. All right, so I sort of reframed the presentation a little bit based on some back and forth with Medard, and I like this idea of designing or engineering for regeneration. I will mention that this website of mine, systemeducation.com, is mostly Bucky short videos explaining some concept of it. And so, of course, since the lab was inspired by the work of Buckminster Fuller, we're going to talk a little bit about it. So don't worry about this. It's an eye test, if you will, but it's just to pull out some of the text from Synergetics. And Synergetics is now all online, has been for quite some time, so you can easily search the two volumes combined. And these are section numbers. You see 000.124 and 125. And really what this talks about is the design science revolution. And really that, for a long time was Buggy's intent, is that we use those ideas to change the world for the better, right? For living, for all people, but also in conjunction with nature, such that we never damage nature. We're in tune with it, because nature, of course, had the highest level of technology, far higher than whatever humans did. So then it seems useful to talk about design. I think, you're going to do some design, and some of you, as I understand it, are already fairly experienced in this, and others perhaps not. And so it's good to have some common language. And so some of this is a little abstract, but I think pretty useful. uh, as you read about design, and of course, there's a lot of people who talked about it. And interestingly enough, Bucky coined the term design science as part of comprehensive anticipatory design science. I don't know when, maybe in the 50s. I haven't actually traced it back. It's been taken up by so many different fields and areas and renamed. Design research is part of it. Of course, design thinking, which we're going to talk about a little bit later. Design science is now a thing in education, where it talks about being effective in what you communicate, et cetera, et cetera. And as you go through it now and look at what all these people have written about design, there's kind of a common thing that says, we're all designers. We all do that, right? When we arrange our homes, when we set up a party or an event, we're doing an intentional arrangement. And they like to emphasize that that could be energy. We could be arranging energy to flow in certain ways. Material, which is what we often think about, right? We often think about a design as a thing. I've made a thing, a pair of eyeglasses. That's definitely arrangement of material, but also it's information. If you put together a poster or anything like that, you're designing it. So then how does design relate to engineering? Well, design is obviously part of engineering. It's generally viewed that engineering is implementing a design. It's such that you can produce multiple copies of it. Other related things, what is invention? So invention, I'll say, is creating a new form. It's different than design. You could design a chair, but you wouldn't necessarily be inventing something. You could invent a whole new kind of chair though, right? Like we have a neighbor who more or less invented a hanging chair way back when, and it's still in production. Of course, many copies have been made of it. And once again, it's energy, material, or information. Now, one of the things we emphasize in teaching and in the innovation community is that invention is not innovation. I like to hold up, my notebooks, which I've got so many of. They're full of brilliant ideas, wonderful inventions that might change the world, but they're not innovations because they haven't been passed on to somebody else. Other people haven't adopted them. So that's a key idea there. There's lots of good material in this area, and I'll put some of the references. Now, this will become I'll be nice, a familiar slide to you as soon as I get my cursor back so I can actually do something. Okay, I'm having this will become familiar with you, and this is from Medard's design science primer that I'm sure he'll make available to you if he hasn't already. And so this is, how he and Harold, I think, Howard, figured out, well, what was Bucky saying about comprehensive anticipatory design? And it's a sequence of steps. And what is the difference between sort of a standard engineering design? Well, we think really big. We think comprehensively, right? So we're super aware of what's out there. We then tune in. We tune into just what we're working on. And then we think about the future. So we anticipate both what might be and what we want to be the preferred future. And then we go through the steps that would be more familiar to most people in a design sense. Now, this is a whole different view of this. One of the things we've been doing lately is working with the Buckminster Fuller Institute and others to kind of update some ideas on, or not update, but communicate more clearly Bucky's ideas on systems change, put it sort of in one spot. And so then you will hear some of these terms in the future, I'm sure, in the course, if you haven't already. Bucky was a really big fan of trim tab, right? A trim tab is the little rudder on the rudder. And so with that little rudder on the rudder, you can easily move a very big ship. And we've dived into that a little bit to kind of take it apart and make it more accessible. Bucky was a huge fan of the idea of precession, which is this effect at right angles. And the famous example is that when the bee goes in to pollinate, or bee goes in to get nectar or pollen, it winds up pollinating. It didn't intend to, but that action, right, of picking up pollen and then depositing it in the next flower is a great example of regenerative design. It aids the bigger system. You get more flowers, which supports more bees, et cetera, et cetera. Tensegrity, it's sort of a little bit beyond our thing today, but basically pretty much everything is paired forces, right? Sometimes there's more compression or, that sort of thing, and sometimes there's more tension. Another one, and I think I'll stop at that, is that he said, don't fight the existing system, creating the model. And of course, there's many examples of that nowadays, and we'll talk about that a little bit later. So lots of good ideas from Bucky on design science and systems change. That's my sort of my key point there, sort of the big one. Now, when we talked about engineering is, well, you've got an idea or you've got something or you want to do something, how do you start and how do you get to the end? So this sort of complicated diagram is what systems engineers do. It's a good diagram though, because it emphasizes that it's not just, oh, yep, here we went off in the lab and here it is, there's your design, right? A system engineer is super aware of, well, how do you make the next one? Where does all that stuff come from? What happens when it's out in the field? Who maintains it? What are the resources needed to power it and repair it? How do you upgrade it? And what happens at end of life? And so this is the V. You start in the upper left, you're saying, well, actually, who are the people that have this challenge? And let's talk to them. Let's find out what's really going on with them and what they really need. And they call that the requirements. So they want to move fairly quickly towards what you might call the design challenge and the requirements, which is produce this thing, this big, that costs this much, that does this particular function. And so then you work your way down the left side of the V and you say, well, okay, let's analyze the requirements. Let's make an architecture. Let's basically then do the design and implement it, right? We're going to have a team working on various parts and we're going to bring them back together. And then we're going up the right side. We're going to integrate those together and then we're going to verify. They say verify. I think the verify is this really what the stakeholders wanted? Did we really build the thing they wanted? This is when you go back and say, well, here you go. Is this really the thing you wanted? And then at some point you validate it and say, does it work the way it was intended? We have these requirements of the weight and the size and everything that we said way back when. Let's make sure that we really got there, kind of a thing. And then as you see on the right side, operation, maintenance, and disposal is part of it. And then this particular slide is part of some work we're doing on natural systems, which is bio-inspired design, plus being inspired by all the forces of nature. And we're saying that the traditional process could be enhanced by considering evolution and of course end-of-life stuff. So this is the bigger picture of engineering, and this will be beyond the scope of what you do, I think, in the lab. However, it's really good to keep in the back of your head. So now that first step where we said who are the stakeholders and what do they really need, I think is handled quite well in what's called design thinking. And this is from Design Thinking Bootcamp Bootleg, which is fairly old now, but still available on the Stanford D School website. And so we've got a couple things here. On the lower left, you can see that there's these 5 main activities you go through. So this is a fairly simple version of a chunk of what we saw in the system engineering process. And the first thing you do is you empathize. And that's where you go out and talk to people and say, well, we hear there's a challenge in education. What is this challenge? I was in a hackathon once where it was like, well, we've got low achievement in certain schools in Minneapolis, and somebody might think, well, I know the answer. Well, I know the answer. Well, have you talked to any kids up there who were up there? Have you talked to any parents that are up there? Have you talked to the administrators? And if you haven't, then you really shouldn't start a design process, right? So design thinking would say, get those people in the room or go out and interview them even better and come back and say, well, here's what we saw. Now you create a thing called a persona, come out of that. But the basic idea is you then sort of feed that back to the initial people and say, well, does this represent, sort of a typical, aspect or a significant aspect of you, the community, that sort of thing. And then you say, okay, we now empathize with it. And now here's what we heard about the challenge. And we're going to play this back to you in our own words. And then we define what we think the challenge is. It's only after that point that we do both those things, that we really interview all the stakeholders and find out what they really think and need. And we have them help us restate the challenge, that we actually go out and do what they call ideation. And this is coming up with ideas. And this is what we typically call design. Now, the fourth one is we then make a quick prototype, more on that a little bit later in the presentation. And we get that back in front of them right away. And we say, well, this is what we're thinking about. And typically, we probably want to give them 3 or 4 things to look at. And then they would say, well, this one looks pretty good, and then we go that way. On the right side, are some of the maxims or laws or recommendations, show, don't tell, use images and that thing, focus on human values, experimentation, radical collaboration. So design thinking is, I believe, a really good way to think about that first step before we actually get too far in the design process. Now, this is one of my mind maps. You'll see more. And we'll make the presentation available so you could actually read the text. And the reason I put it in here is that in this empathize, and hopefully you'll do some of this, during the lab itself, is they recommend, use your beginner's mind, put away your assumptions, just pretend you know nothing about it. The what and the why and the how are things you can talk to people about, like, well, what is the deal and how do you do it now? And why is it done the way it is now? And why would you do it differently? That sort of thing. Many other things here, and I won't get all into it, but there's a lot of simple tools, and these are all in that bootleg, and the link was in the previous slide. So then the question is, design for what? Okay, and you've got a subject for the lab, so we got that, but I just want to bring up some what I think are really good examples, because in the future you might do things slightly different. So this is the design for extreme affordability. And Fred Rose, who founded the ACAR Institute, which is now part of Institute of the Environment at the University of Minnesota, talked to a company I worked for decades ago and said, this big company I work for is interested in sustainability, but we'll never come up with sustainable solutions in the United States, right? Energy will always be cheap to us. So we've got to go over and work in other countries and find out what really works. And then if we've got a solution for them, then we can bring it back and it'll help work for us. Out of that sort of thinking came this design for extreme affordability. And so this is, 4 of dozens. It's similar to Global Solutions Lab past, products or the BFI Challenge Idea Index. So there's a lot of good things to look at, and it's a good perspective is that, design for extreme affordability. I'll give you one more. So, and I've lost the context for this. So it's a true story, and I can come up with the context of who it was that did this, but someone visiting a country in the Middle East, and they went in a hospital and they looked in the room and there's all these fancy machines just sitting there. And they said, well, what are those doing there? Well, they were incubators for premature babies, and they were sent over, but they all eventually broke, and there's no supply chain here to fix them. There's no way to get the parts. There's nobody really understands it. So we don't actually have any incubators for premature babies anymore. And he's like, oh, well, what do we have? We have a lot of broken down old cars. Oh, well, what's in a car? Well, there's a headlight that gets pretty warm. All right. What do we need? We need a box, and we needed a way to control the temperature. So, with literally, a few dollars and existing stuff, and you could run it off a battery, right? Which meant you didn't have to worry about interruptions in electricity. Came up with a very simple approach to it. This is related to a thing that I'll mention, and I'll get a reference in, which is reverse innovation. And so reverse innovation is a developed world, or whatever, whatever the appropriate term would be. So like another example would be, one of the big healthcare companies was going to design a brand new, fancy medical device for use in hospitals. And somebody said, well, how would we make an expensive one that would work in Africa? And they said, well, we have no idea. And I said, well, why don't you go over there and figure it out? Because once you figure that out, right, then you'll actually have some really good ideas to make simple stuff over here. And they did. And they found out, oh, it needs to be about 10% of the cost. Oh, it needs to be about, just a fraction of the weight. Oh, it has to work on variable supply energy, right? And so then they were able to do that. And they were able to produce, a compact, low power, more resilient design. And guess what? They brought it back into the United States, which is where they're located, and it did increase their market. So there's actually books on reverse innovation. All right. So then another one would be Engineers Without Borders. And I had some involvement with them a few years ago. They're still around everywhere. one of the things that they figured out was when designing things for other countries, you needed to have a plan to maintain it. And so they had done a few things where they went down, let's say to Central America, had a brilliant design, came back a year or two later. And once again, like the incubators, they're just laying there not used. And why? Because something had broken. There's nobody there who knew how to maintain it. They didn't have the spare parts. And they said, okay, we're only going to take on projects now where we can make a 3 to 5 year commitment to maintain it and make sure the local people, can follow up on it. So a lot of great examples here as well. And they've got several different ways you could interface with them. So once again, this is probably beyond the scope of the lab, but I wanted to make sure you guys were familiar with this stuff. And then one more. And so this is the ACARA challenge, which has changed now. When I was involved with it, when Fred Rose started it, it had a focus on India, and it had a focus on fixing things like leather tanning. There's a huge amount of leather tanning in India, and it's regulated, but the laws are just never enforced, at least at the time. And so then what they would do is they'd get a university in India and they get a university in North America or Europe to work together to come up with ideas to make a solution that would make enough sense that it would not require regulation to implement it. So lots of interesting stuff. And I was on, panels, judging things, and really good stuff. The program has changed now, and but they still have all the archives, and it's just another good example of this sort of teaming and working directly with people to say, well, here's a challenge and how can we solve it in a way that makes sense for the local community. All right, so this is that first thing, which is, well, oh yeah, I want to do something, want to fix something. Well, have you talked to the people? Well, no. Well, then you need to talk to the people. What is the real challenge? Well, it could be this. Well, it could be, but have you talked to the people? So this is the next thing, this is the framing of it. And then you go off and you do this, what I call ideation, which is come up with a bunch of ideas. Often in design, we say, well, first thing we do is we diverge. We have many possible ideas. And then we have some way to rank or sort them, right? And then we converge in a single one or two. So as we do that, we've got to take a look at these ideas. We have to reduce them to practice. And this is prototyping. And so once again, kind of an eye chart, apologies, but we'll make the slides available. So what's a prototype? Everything's a prototype, right? Products, process, life is a prototype, right? I could go on and on about this. I'll also put a link in for Tom Chi and his videos on rapid prototyping, how to do something really quickly in half an hour, inexpensively, just to get some idea. Consider your prototype as an interview with the client, that it's unfinished. You're just saying, well, what about this, right? So it's not pretty, it's not special. You didn't spend a lot of time, making it fancy. In design thinking, they say it's better to be made out of 2x4s, because then when the person sees it, it won't be so nice that they'll say, well, I can't really critique this, it's so nice. But if it looks pretty rough and it looks, not quite done, they're more likely to be able to say, oh yeah, well, sure, I'll tell you something about it. So you're using it to understand, to come up with alternatives, to understand this and that, use it to communicate, to test and improve, and sometimes just to explore. Like, is this the kind of thing that would help, electricity generation? Is this the kind of thing that would help resilience with supply interruptions, right? You might need just explore the area of prototypes before settling on a thing to do. Okay, so now back to Bucky. So once again, remember that comprehensive anticipatory design science. That first thing is comprehensive. And so then, this is the big picture view. And this is from Amy Edmondson's filler explanation. And she's just restating what he said so often, which is, we tune in to a particular level of system. And that's totally fine. We come in the room and we focus on the chair. We're aware that there's walls and air and windows, but they're sort of out of scope. We're aware there's elements within the chair, but once again, they're out of scope. And so then he has a number of figures in synergetics. This is one where it just emphasizes this kind of a frequency thing, right? We're tuning in a particular kind of frequency to get a certain level of scale. And here's another one, which is, the same but different. And I include these just because of what they're really emphasizing. We're seeing systems, and the point to me isn't so much that we see the system. This is once again the challenge, or this is the person, the stakeholder, whatever that we're empathizing with. we're also understanding all the stuff that surrounds them, right? Because that affects what's happening in this challenge. We're also understanding what's happening inside this, right? Because there's systems inside it, and they might be resources, and they certainly have to be considered when we work on our designs. So we're doing the zooming in and zooming out till we decide. And then we say, okay, well, here's today. Here are the behaviors today. And the behaviors today are the result of structures, mostly invisible structures, right? We act in ways based on the way we think, right? Based on the way, economics are structured, based on the way people expect. And so that's why behaviors happen today. And guess what? Behaviors tomorrow, if we want to have a different system, a different future, we have to change behaviors. Well, what does that mean? We've got to change structures. We have to change those feedback loops and those goals, and et cetera, et cetera. So I think it's useful to use this zooming in of Bucky's in two ways. And one is sort of the present, and the other one is more towards the future. And now in some of the work we're doing, we've said, well, another way to think of it is, as Bucky emphasized, that, it's the universe is full of systems interacting, right? All kinds of, systems just, interacting in different ways. And so it's really a 3D situation. And so then this is a little better view. You can kind of see that we start to draw the systems in the middle. And by doing it, we've kind of described a boundary. And what I don't show here is it's the systems that are inside that actually compose the boundary, right? So the boundary is made up of how these systems are connected together and how they allow things in or don't allow things in. So a little abstract, but I think it's useful just to keep in our mind that it's all about systems interaction. So how do we get here? Well, in design thinking, they have a method sometimes called flurry of Post-it notes. And in flurry of Post-it notes, you have a big whiteboard and you have people in a room, and they go up and just start putting stuff down that seems important. Oh, Sally's important. Oh, this kind of a flow is important. No, that kind of a thing is important. Here's a goal. Just put a ton of stuff down. And then you go up and somebody rearranges them into, well, here's all the Sallys and the Freds. Okay, and here's all the flows, and here's the goal, or here's the inputs, outputs. You start to build this systems map. This is also known as, another version of it is known as rich picture. And so this is a rich picture of somebody in their job, like kind of overwhelmed by the job. And there's a great book called Growing Wings in the Way, where the author talks about an elderly parent, and she and her sister were concerned, was mom able to do this stuff? And they said, well, what are we concerned about? And so they started to map out, well, is she taking care of her health? Is she paying the bills? So they mapped all the stuff out, and then they're like, come up with all the loops. And then they came up with things that they could possibly do to check in with her and help her get through the stuff. So rich picture is another way to do it. And yet another one is called giga mapping. Now you have big sheets of paper that cover the whole conference table, and everybody just starts drawing their bits of it, and you start to combine them. And of course, you can do this online now with Mural or Miro or any of those tools. Now, an interesting thing in here is that Bucky emphasized that systems are relations, not the corners. We like to label the corners or the nodes and say, oh yeah, that's what makes the system, but it's not. It's how they're stuck together. It's the relations. Remember we talked about the feedback loops and stuff? It's that. And so then this is CMap tools, which is a freely available concept mapping tool. And one of the nice things about it is that as soon as you draw something, it puts a question mark in the middle and says, well, how are these things related? So this was a way to look at regenerative agriculture in a local sense. Like, how does a household make choices, right? How does it make choices today based on what's available today? And how might it make choices in the future? And we start to look at that. And now one of the things that it's actually in the Cabrera's, Derek Cabrera and his wife have done a series of books on systems, and they emphasize that the relation itself is a system. So we start to look at the relation, the flow, or that force, or that interchange, or whatever it is. We can zoom in. Like if it says influence, so what does that mean? Well, it's got to have a channel for the influence. You got to talk to somebody, or they've got to see what you're doing. You got to make an advertisement, right? And so you can zoom into the influence, and of course, then you could zoom into all those things. And it's a very Bucky idea, by the way, of zooming in. So we're just saying, just start it. You click a couple things, it's got question marks, you fill them out, and it'll prompt you to fill the other one out, and then you can change how the arrows flow. So now we're jumping back to a previous topic, which is you want to change the world. You will change the world, right? Sometimes it's really hard. It's really hard because, once again, like I could have this perfect product, but if it requires Medard to change his behavior, he might not want to. He's just happy with what he's got. He doesn't know about mine. It might look expensive. It might look like it can't be maintained, whatever. So what we have to do is, and this is kind of too busy of a slide, but you'll get the idea that there's the old system, which is high on the left side. And over time, the old system is declining, right? And so then if you want to come up with a new system, well, guess what? You have to do something to transform the old system. And so all those things are Post-its that are ideas about transitioning the old system. But at the same time, you want to improve the new system or enhance it or, propagate it. That starts at the lower left and you want it to come up, right? And so there's a transition in there. And so this is just a reminder that it takes activity in both ways, right? To get people to sort of say, well, yeah, boy, it was sure easy to do it the old way, Curt, but maybe I'll try the new way a little bit, and different strategies to do it and that kind of thing. And then, like we said, this stuff is all invisibly held in place, right? Feedback loops, expectation goals that we may not have talked about. Now, the advantage of the mapping, especially if you do the mapping with somebody else, and you have to do the mapping with somebody else, because none of us can view a system, right? If you take a look at a system from one angle, and then you move behind me, you'd see a different aspect of it. And so the advantage of mapping with other people is you start to say, I see a different point of view. I see a different way to change it. I see why that's happening. It increases your understanding. And then you also say, I know why Curt thinks that way now. He always says that. I never understood why he thought that the organization was X when I thought the goal or organization was Y. And you may not come to a resolution, but at this point you can understand each other better. And now we're going to jump back to that thing, which is related again. So to some basic Bucky, if you're trim tabbing a system, you're changing the direction of it. You're not really transforming it deeply. If you're using this procession, this is kind of a systems coupling thing, right? Where you have these components that are coupling in different ways. And it turns out there's always two interconnections, more on that in a second, in the pollinator and the flower. The other way to view systems coupling is not so much procession, but just that there, for anything regenerative, there needs to be exchange. If we're just extractive, right, that's beyond, that's extractive, exploitive, or whatever. It's not sustainable, certainly not regenerative. Because once again, regenerative is improving the larger system, right? And that larger system is environmental, and it's social and cultural, and it's informational. So right now we're being regenerative because we're learning together on stuff. Like, I'm going to learn from you, and hopefully there's something here that's useful you'll explore. And then we're creating a new model. And I think the commons tools of Eleanor Ostrom, there's certainly not things Bucky came up with, but what she won the Nobel Prize for economics by going out and studying places where commons were being managed effectively, and produced a set of rules, a simple set of rules for how you do that in terms of a fishery or a forest, anything like that. And those are old, but they're actually new models that still work, if you will, right? They're a different way of doing than the extractive, exploitive, private property approach to it. And so that's one. Microcredit, I'll say, is another. Universal basic income is another. Social innovations are another. So there's many new models. So it's the other way of systems change. And then you need the design to get to these places, right? And you need to prototype, get the feedback, and work in the transition. Okay, so there's a little bit on systems coupling. This is the famous illustration from Synergetics, and a little bit hard to see, but you can see at the lower right is that extractive one. And he talked about it in terms of water, right? With water molecules or gas molecules, they can just freely go all around. With this, coupling of the two edges, they're hinging. But once again, that implies that there's a force going one way and a force coming back the other way. And that I'll assert that that's how you have systems to sustainability in terms of long-term, and also regenerative. And then finally, you get systems that actually sort of, connect together with more than 2 points, and now they become the super system, but they still have all the complexity inside of it. And so that I made a slightly different version of this. This is in a thing called VZome, which is virtual Zome tool. If you know Zome tool, it's easy peasy to use, and just showing, that these systems aren't these, sometimes we say, well, these polyhedrid, they don't make sense. They're static and they're fixed. Well, they're not. They're just dynamic and coming in and out. They're here for a nanosecond or a microsecond or whatever it is, and change, and they have lots of complexity, right? Like cells are tensegrities, the way they move and the way they're interconnected, and they're very dynamic. All right. So there's a bunch of stuff on that. So then I want to say a couple more things. So when we do, come up with a new idea, and once again, this is a systems issue, old systems versus new system, we do need to think about, okay, here's this new system. Remember my examples of people dropping this brilliant solution in Central America and coming back and it wasn't being maintained. So the bicycle to me is like the ultimate sustainable design. Why is that? Well, it's modular and it's standardized, right? The wheels are all a particular size. I mean, there's some variations, but what I'm saying, chains are pretty darn, similar. The gears are pretty darn similar, right? The seats, the handlebars, okay? So they're produced by all kinds of people, all kinds of places. You can easily repair them, and et cetera. All right, go look at a new e-bike and look deeply at it, right? They're all unique. They all have their own special battery. Okay, in a year or 3, when the e-bike thing is sorted out into the bigs, those smaller companies, you won't be able to maintain those bikes because those batteries were made for that design. They were specific for that design. I know this from product design. So, I mean, if they were made in higher volume, somebody probably out of China or Southeast Asia will make, a similar version. But this is a really good thing to think about, that to the extent we can use standard parts and come up with something that's, going to be available for a long time, we're going to make sure that we've got a good design, basically a maintainable design. All right, so now I'm going to switch to a whole different thing. And I'll talk a little bit about biomimicry or bio-inspired design. So this is the biomimicry design lens. It's freely available. And I think this version is from B3.8, which is the consulting side. There's 2 institutions, B3.8, which is what they call biologists at the design table, and also the Biomimicry Institute, which is the educational part that I volunteer with. And so then this shows the process, and the 10 o'clock position is scoping and defining. Okay, so this is kind of what we talked about before, wasn't it? This is the empathizing and coming up with a challenge. And one of the things that they are really good at saying in bio-inspired design is everything is local. What is the context, right, where you are, right? You can't necessarily take a solution from a whole different ecosystem and have it work right here. So once you, define this and get a good idea of what's around it and where it is today and in the future, you got a good start. Then they say, identify the function you need. And so this is an important part of design as well, is we say, well, the function is, and if I pause for a moment, a function is typically a 2-word phrase. And the first word is a verb or an action, and the second is a noun. And so then I could provide energy. I could, move a rock. Okay. I could transport a document. Okay. And so when you have the abstracted function, then it allows you to search for a much wider range of alternatives. And it turns out by keeping it at an abstract level before you jump down to a level of, oh, you need to move documents regularly, so you need a car. Well, maybe you don't. Maybe it's a bike, maybe it's electronic, maybe it's something else, right? So keeping it at an abstract level really works. Okay, so the next step in the biomimicry design process is the integrate life's principles. So what are those? That's the way life works. That's how things are structured in living systems. And to the extent we follow that, we have sustainable or better yet regenerative solutions. To the extent that we don't, if we do what Janine Benyus called heat, beat, and treat, right? Extract, with steam shovel or whatever they would call it now, diesel shovel, earth and transport it in diesel powered dump trucks and put it into a fiery blast furnace to make aluminum. They call it smelting. That's heat, beat, and treat. Nature does not do that. It uses only local materials, local energy. It doesn't do all that refining operation. When it puts things together that can easily be taken apart, and on pretty much every aspect, they are superior to any of our designs, like spider silk is stronger than steel, et cetera, et cetera. So what they're saying is at this point, before you even start to go look for ideas, you're going back to say, okay, how would I make sure that in my, my end solution, I'm integrating life's principles. So you're looking at this early on, as opposed to looking at it at the end to say, oh, did we fit? They're saying, look at it early on, and we'll see these in a minute. Then you finally go search for solutions. You discover, you abstract, you brainstorm, you prototype, et cetera. And I put this one up because this shows this kind of a strange path around these things. When they put it together, they assumed, oh, everybody will start at 10 o'clock and work their way clockwise around the clock. But then when they talk to companies that use it, they said, well, actually, sometimes we do this. We get inspired by a model and then we abstract it and then we say, oh, well, what would we do with it, et cetera, et cetera. And so like any design process, we pretty much figure out after the fact what we did, and we just need to make sure we hit all the steps. So just the little thing on that. And then this is life's principles. And so around the outside are the very biggest ideas. And those are probably hard to see, but consider cyclic processes, sunlight, water, gravity, dynamic, non-equilibrium, and limits and boundaries. And then in the green, you have the sort of the big subcategories. You adapt to changing conditions, you be locally attuned and responsive. And under adapt, for example, it says incorporate diversity, maintain integrity through self-renewal, embody resilience through variation, redundancy, and decentralization. So these are really good ways to evaluate our design, and also really good ways to look at a situation and say, how could we improve it? Because this is kind of the short form of regenerative design, right? Because this is how nature evolved and operates, and it's the eternal regenerative. That was one of the things Bucky said. And there's another version of this that's from a book called The Way Life Works by Hoagland Dobson. And just a different way to view it, that life is structured, it builds from the bottom up. And this is a good point to say that when we do what we call systems architecture, when we're looking at that point where we're saying, here we have a challenge, how do we fix it? It's really good to look from the bottom up as well as the top down. We tend in design to look from the top down, or what are the big challenges that we have to do? And then we sort of differentiate those into subcomponents, then we solve the subcomponents. But all the books on system architecture says is you can do that and you should do it, but you should also start from the bottom up. So we have both a bottom up process and a top down process for best design. So anyway, this is a nice little reminder of how this all works together. So how life is structured with boundaries and insides and outsides. It's modular. Remember the modularity of the batteries, not so much, and the bicycle wheels, yes, better. It organizes the information, maintains via turnover, etc. So good stuff there. Here's asknature.org. I think it's slightly stale, looks a little different, but just go there. And the prompt is, how does nature? And you just type in a word and just see what you get. And you get lots of examples from nature, as well as what they call strategies, where people have used the idea to create a new thing. It's organized according to a taxonomy of function. And so the middle, the green is the high level functions, like how does life move or stay put? And the subgroup is, well, does it attach or does it move? And then the subgroup is permanently or temporarily. And then there's solids, liquids, and gases, and all the way around. So it's nice to see, because it's a good reminder of all the ways to do a thing. Okay, so once again, we're talking about innovation. You're coming up with ideas, and you should consider social innovation, right? And to me, this is another one of, creating new model. There's so many things out there. This is the set of guidelines from the Intergalactic Design Guide by Heller. What does it start with? Context. Who are the people? What are they doing? Look from the inside out. Find out how people see themselves. The process is the strategy. You learn by doing it. You don't come in saying, well, here's how we're going to innovate or whatever, right? Yeah. Human capacity is the goal. You're experimenting and prototyping. This is a great set of stuff to remember. And then one more, this is pretty much Carol Sanford's work, and if you haven't seen her work, it's great, super practical. Regenerative design, you design for evolution. You understand everything is nested, okay? You partner with place. Guess what? That's the whole context thing again. You have this collective vocation. Aha, well, that's talking to the people, right? What you want to come up with is something where they're more involved, where they're doing more of it. You know, maybe it's a lower energy version of it, but if they have more involvement in it and it provides more of a living wage, that could be just the way to go. And there's more here, working with potential, co-evolving, etc. It's good to remember, as Bucky said, that systems are relations. And we have these great examples that are out there. You know, take a look at the soil food web. Look at one of the recent books on fungal networks, right? And what's happening in the tree roots and how things get transformed in both of organisms thrive. You know, higher level, ecosystem level down to the cellular level. And of course, the slime mold I mentioned before is a great example of bottom up, as is ants, you know, simple rules, complex behavior, bees, same. Okay. And so then it's good to remind you that Bucky said we should continually remind ourselves of different ways of looking at the world, what he called design science strategies. Your formulation is from comprehensive. Remember, that's the big picture view we started with, to the particular. We're tuning in. We're aware of nature's coordinate system. The things are stuck together like this. There was a saying I just ran across: molecules invented geometry. It's really, in a way, what Bucky was saying is there's a geometry of nature which is driven by, you know, pretty much how elementary particles and up, you know, associate. We're aware of geographical reconnaissance. What does this mean? Context. Right? Bucky was like, context. Where are you at? What do you have? What can you use? Locality. And then many other things that he put into it. So yeah, but that's enough. And that's about 45. So I think that was the goal. So I'm going to stop sharing. And
so Curt, the way we're going to ask people to ask questions is they're going to write them in the chat box, and then I will read them and let you respond. It was a thank you. That's my most important message right at the moment. Thank you for your talk. There was, to say the least, lots of information about an incredibly important topic or topics. So when anybody has a question, I think some people have been overwhelmed by that and don't know where to jump into the questions. So one of the questions that I have for you has to do with the relationship of biomimicry, of the idea of using nature as an inspiration for design, using it as a template, you know, looking at nature and seeing what she does and how that might apply to what it is we're doing. Is there what would be a procedure for doing that? Let's say if you wanted to figure out how to use nature in whatever, let's say getting electricity to Africa or getting food to hungry people. What ways could one use the principles of biomimicry to think about solutions?
All right. Well, so context, right? We'd say, well, where are we working? You know, what is happening here? You know, if possible, we go immerse ourselves in the place. The biologists at the design table have a thing, which is the exemplars or the champion adapters. So if you go into the desert, you know, what are the organisms that can survive on really low water? Because you need to do something in the desert. You know, you look at those because they're really inspiring. So one of the things is just to start with, where are we working? Because it's all local. You know, we can't come up with one system that's going to work everywhere. Okay, I mean, if it's got modularity and can be evolved and can be adapted, maybe. but really we need to start with one spot. Okay, and then we'd say, well, how do we take it apart? When we say providing food, well, what does that mean? Well, first of all, food has to be grown. So we might say, well, let's just look at growing food right now, right? And then we'd say, well, then maybe it has to be stored. Maybe there has to be refrigeration. Maybe it has to then be transported. Okay, so you can see what I'm saying. We start to break it down and say, well, the part I'm working on right now is this, okay? And then we'd say, okay, in growing food, what are the main things we need? What are the main functions we have to satisfy? And so, there's nutrients, obviously providing nutrients, there's seeds, there's a certain amount of, responding to environmental conditions, if you will. And so then we'd look at each of those and we'd say, well, how could we describe those in a more general sense as a function? And so we could go into Ask Nature and say, provide nutrients. How does nature provide nutrients? We'll find gazillions of examples. And we'll find both examples from organisms and ecosystems, as well as we'll find a dozen or more ideas where companies have tried to use the ideas that nature provides for providing nutrients in a design. So that's how we would do it, is we'd kind of do this sort of, you've got to have the big picture view, but we can't solve the whole thing at once. So then we kind of look at the individual parts and we do the abstracted thing. And of course, once we say, well, and then when we go search and we say, oh, providing nutrients, well, how many, look at least 8, maybe a dozen things from nature and sketch them out really simply, because that's how you really understand it. And then talk to somebody else about your understanding of it. And then you pick maybe the top 3 and say, well, okay, nature uses this strategy to provide nutrients, this, and also this strategy. And then you say, well, okay, how could we do that in a human design system? So that's kind of the last step. And then you get into the normal stuff we talked about before. And then just one more thing, I'm sorry if it's, once again, too much, but what they'll emphasize in biomercury is that you can work at the level of form, like you've heard of the kingfisher beak and the bullet train. That's the level of form. And then you can work at the level of process. So that's pretty interesting, because you can look at maybe how evolution has variation and selection to come up with different things, how it uses modularity. But finally, you can work at the level of system. And they'll emphasize that the biggest wins, if you will, come to the level of system. Now, clearly, a specific example of a train and a form, to reduce the noise, that's great. But if we come up with a systemic solution where we never have the issue, it's deeper yet. So something like that would be the idea.
Okay, bunch of questions. One more related to biomimicry, and then the others to the design and getting started. What's an example of biomimicry in design that is most intriguing to you? Are there examples of biomimicry present in your life?
I love questions, and especially ones that have me like thinking deeply. So I want to say that one of the more inspiring things lately is there have been a number of places that talk about using biomercury for social innovation. In fact, there's an organization called Biomercury for Social Innovation, and has a set of inspiring cards, which I think are based on leadership. And you can just pull one out and say, well, how would I use inspiration from nature to be a better leader, to be, to help this team, do better. So I think that's pretty inspiring. So we're completely off grid here. And so that means we've learned how to do micropower stuff, because we have a tiny, tiny solar system, nothing like you see the huge arrays. We have 4 solar cells, solar panels for the house. And what that means is we only run the washing machine when the sun is out. We only run the flour grinder when the sun is shining, because then we have excess. And so we learn to live with the cycles of nature. So I guess that's an easy example, but I'll try and think of a better one.
Okay, quickly. You stressed how important it is to actually talk to people you are designing a product for. And this person is wondering, is there a specific manner in which to do so? That is there a certain way of knowing who exactly to contact or how to talk to the people in order to get the answers you want or need?
Yeah, really good. And so, and it's also like for most of us, I don't know who those people are. How would I do this? And so I think in the hackathon where we didn't know, we just started walking around outside the neighborhood we were in. Well, unfortunately, we weren't in the challenged community, right? We didn't do it as well as we did, but by just doing a walkabout, we started to get information we didn't have in different perspectives. And then they say that, when you're like looking for a job or a resource, there's sort of three kinds of contacts to make. One is, yep, I've got that. I can get that for you. And the other one is, well, I don't have that, but I know Medard, and Medard knows, knows people who know that. And then you finally have people who know a lot of people. And so then if you wind up with somebody who says, Joe, I really don't know about it, then you can ask them second question. Well, do you know somebody who might know about it? Like, do you know somebody involved in the schools in that part of Minneapolis? Well, actually, I do. I've got a neighbor, go talk to my neighbor. Or, and if that fails, you can always say, do you know somebody that knows? And then sometimes you just have to say, well, thank you very much for your time and go to the next one. The other thing is you work with local organizations, right? So somebody that's already doing work in the community, that's already, helping people with issues. And you say, we want to do this thing. We obviously want to talk to you guys. We also want to talk to people, that you're serving. How do we arrange it? So, and then you use the tools, the empathize tools from that design camp bootleg, because they have a lot of pretty simple stuff. And it's, it's interviewing for empathy, they call it, which is like not assuming, just asking questions and trying to get a sense of where they're coming from.
So here's another one. You presented a lot. And this question is related to that. There's many different methods, can be overwhelming. How do you start?
Right. So there's just really, and I should have had a wrap up slide. So that's a good reminder. I'll put it in the presentation before I send it off to you, Dar. So what did we really say? We said it's a systems issue, right? Today and tomorrow, whatever that means, but you have some sense of systems. And so that first thing of getting a view of what is, a lot of that is talking to people. If that's all you take away from presentation, that you should talk to people before you start, you've got like 80% of it. And then another one is that you don't assume that the first thing is the correct thing, right? You're doing this rough prototype and there's a zillion ways to do it. And you can prototype anything and everything. It's good to remind people that, like, for entrepreneurs that have started successful companies and successfully put something out there, like 80% of them pivot. What does that mean? They have this brilliant idea and they go put it in front of Curt and he's like, I really can't use that, but that little feature over there, that's a really cool feature. You should work on it. And when they listen to that and they do the pivot, then all of a sudden they change the product. So assume that your first idea, once you get it back in front of people, once they look at the rough prototype, you're going to pivot it, you're going to change it. And guess what? You got somebody now more involved in the process. That's an ally later on to come back and say, well, here's what we have now, and that sort of thing. So it's that kind of a process is, remember it's a system, and that means talking to people involved that are doing the work and, the enablers and the whatever's, right? And then, when you come up with something, don't get too attached to it, because this should be rough and they should give you good feedback and you're probably going to pivot and etc. Those are the kind of key things. And there's a lot of stuff in there about, well, okay, you think you've got that, but how do you come up with the idea? A lot of the stuff in there about biomimicry and social innovation, that was like different ways to approach it. And that's where there was a lot of complexity. And the point there is you don't have to absorb it all now, but it's good to have in the back of your head to look at later.
Right. Yeah. Another question. You said that innovation is having users adopt your idea, but isn't innovation the improvement upon an existing invention of ideas, theories, and ideas and plans? Not sure what the question is. I guess it's trying to verify that understanding. Is it just, I guess that's it. Innovation is having, if you get that, please respond to it.
Yeah, no, I do. Yes, I think we all see innovation as, oh, geez, boy, oh boy, that's innovative, right? But if this were the only cell phone you'd ever seen or smartphone you ever seen, it wouldn't be an innovation. It would only be an innovation once Medard has one and we can talk to each other, right? And so that's the point about innovation, is that you got to move beyond the brilliant idea to the adoption of it. And so then that it's that first user basically who says, well, sure, you're crazy, man, but I'll do it. There's a famous example from a thing called Ethernet that some of you may remember. It's when we used to connect computers with these cables, right? And we had high-speed transfer. So the guy that invented it, there it is, it's brilliant, I'm done. Who did he sell it to? The companies didn't want it, they didn't understand it. He said it took 100 visits. Okay, and this is him flying to a city and setting up a thing and going into a conference room and saying, well, here it is, there's all the data, took 100 visits before somebody said, well, sure, we'll try it. Or the famous thing about Colonel Sanders, right? However many 100 times he got turned down before somebody said, sure, we'll try your recipe, right? And so it takes a long time to get the first one, but that's when you get the innovation. Like I can have a brilliant idea to do something, but until Medard or Fred picks it up, it's not an innovation. That's the point there. But yes, to be picked up, it needs to be an improvement. And there's a whole other discussion we could have about, it's really what we call a value proposition, right? An innovation, either like with the cell phone again, it's got more stuff in it. It's got more coolness, right? It's got a camera, it's got a this, it's got a that. Okay, that's one way to improve it. The other one is reduce the badness, right? If I make it smaller, make it lighter, make it last longer on the battery, make it recyclable. I've also made it a higher value, it's innovation, and I can probably get someone to adopt it.
Here's the last question that's shown up here. How can biomimicry help in developing new materials?
Yeah, that's one of the key things that's happening right now. I would say that every scientific and engineering organization has a branch devoted to biomimicry. They don't always call it that. They might be bio-inspired, biomimic, bionic, bio whatever. But a person to look at is Julian Vincent. I'll make sure I put a link to his work in the references, and it's all up on ResearchGate. He's written textbooks on this. And so once again, nature builds from local materials, right? Doesn't use excess energy. It tends to make materials as composites, right? So bone is a composite, and which means it's super strong. But guess what? Everything from nature, this material is recyclable and has all these properties, right? This, that we want and need. So it's just a huge, huge area. I can't really do justice, but I'll put a link into Julian's stuff, and he's very contactable. If you send him a note, he's going to respond to you, and he's like one of the world's key people in this area. So.
All right, Jawaria, you're here, and I'm wondering if our next speaker has arrived. I have not seen her. I need to know that because I want to move on from Curt if she is here, but if she's not, we can keep Curt possibly a little longer. He may have things he needs to do in his life. So Jawaria, can you put your camera on and respond, please?
Yeah, Wayne?
Yes, I can hear you. Is our next speaker here? You don't know. Okay, our next speaker from the UN Environmental Program in Nairobi. I checked my emails, a minute ago, 30 seconds ago, and haven't received anything. So we don't know whether she's having problems in connecting. I wouldn't hope that she wouldn't, given where she's coming from, that the UNEP ought to have good access. You should have her email, Jawaria. If you can email her and find out what is happening with her, that would be a good idea.
Okay.
Meanwhile, I will proceed.